You ever stop and think about how your Wi-Fi actually works? I mean, really think about it. You've got your laptop, your phone, a printer, a smart TV, all in the same room. How does your laptop know to send a print job to the printer and not your TV by mistake? It feels like magic, right? Well, it's not. It's all thanks to this silent, super busy little protocol that's basically the network's own private phone book. Let's get into it.
So that's the big question, isn't it? We're so used to just clicking on things or typing in web addresses, but down at the very basic level, how does one machine physically locate another one when they're on the same Wi-Fi or plugged into the same switch?
Okay, to answer that, you have to get that every single one of your devices has two different kinds of addresses. First, you've got the IP address. Think of this like a person's name. It's a logical label and it can change. It's what we use to route stuff across the giant network of networks we call the internet. But then there's the MAC address. This is more like a permanent desk number in an office. It's a physical, unique address that's literally burned into the device's hardware.
And that brings us right to the heart of the problem. You can't just send a package to John Smith in a huge office building. You need to know he's at desk 4B on the 3rd floor. It's the same on a network. Knowing a device's name, its IP address, isn't enough to talk to it directly. You need its physical location, its desk number, its MAC address. So how do we connect the name to the desk?
Well, the answer is this wonderfully simple and elegant protocol that acts as the network's official translator. It's called ARP, which stands for Address Resolution Protocol. And honestly, it's the unsung hero of your local network. So what is ARP officially? It's the set of rules that lets one device ask another for that critical piece of information. It's the bridge that connects Layer 3, the world of logical IP addresses and routing between networks, to Layer 2, the world of physical MAC addresses and direct device-to-device chats on the same network. Without ARP, none of that local communication would happen.
And the process itself? It's actually surprisingly simple. You can think of it like a quick little 3-step handshake that happens anytime one of your devices needs to talk to another for the very first time. Let's walk through it.
But wait, before we see the handshake, we got to talk about the network's short-term memory. It's called the ARP cache. Every device on your network keeps a small, temporary list of the IP addresses it's talked to recently, and the MAC addresses that go with them. This little cache is absolutely key for performance. I mean, can you imagine if your computer had to ask for directions every single time it wanted to send something? The network would grind to a halt.
So here's how it all goes down. Let's say your laptop wants to talk to your printer. First, your laptop just shouts a broadcast message to everyone on the network, saying, hey, who has the IP address 192.168.150? Every device hears it, but only the printer, which actually has that IP, sends a direct reply, a unicast, saying, that's me, and here's my MAC address. And then, for the final step, both your laptop and the printer jot down that information in their ARP cache, so they don't have to ask again anytime soon. Simple, right? It's a really beautiful and efficient system.
And just so you know, this isn't some rare, obscure thing. This exact broadcast, reply, and cache update, it's happening constantly, hundreds of times a minute, completely silently in the background on your network right now. It's the chatter that makes your digital life possible.
Now, that basic request and reply system we just covered is the bread and butter of ARP, but it's not the only trick up its sleeve. Over the years, a few different flavors of ARP have popped up to handle more specific, kind of tricky networking situations.
For instance, there's something called gratuitous ARP. This is where a device just announces itself when it joins a network, kind of like walking into a party and saying, hey everyone, I'm here, and this is my IP address. It's a good way to make sure no one else is already using its IP. Then you have proxy ARP, where a router will cleverly answer ARP requests on behalf of devices on a totally different network segment. And then there's inverse ARP, which, as you might guess, does the exact opposite of what we've been talking about. It's for those rare cases where a device knows a MAC address, but needs to figure out what IP address it belongs to.
So for all its brilliance and efficiency, ARP has one huge fundamental flaw. It was built in a time when networks were smaller and more trusted. It was designed to just assume that every device is telling the truth. And in today's world, assuming trust is, well, a very dangerous thing.
The whole system we've just laid out hinges on one simple idea, that devices are honest about who they are. So what happens when one of them decides to lie?
Well, that's when you get something nasty called ARP spoofing or ARP poisoning. Basically, an attacker on your network starts sending out fake ARP replies. They'll tell your computer, hey, you know that router you're trying to talk to? Yeah, that's me. Here's my MAC address. And because ARP is built on trust, your computer just goes, oh, Okay, and updates its cache with this totally bogus information.
Under normal, happy circumstances, the path your data takes is simple and secure. It goes from your computer, straight to your router, and then out to the big wide internet. Clean.
But after an ARP spoofing attack, that path gets a detour, and you'd never even know it. Now, your data flows from your computer straight to the attacker's machine. They look at it, maybe copy it, and then forward it on to the real router. They've just wedged themselves right into the middle of your conversation.
And the consequences are, well, pretty bad. The attacker becomes the man in the middle. They can see everything you're sending, passwords, bank details, you name it. Your private data is no longer private. Your entire connection has been hijacked, completely without your knowledge.
So really, the big takeaway is this. ARP is the invisible, absolutely essential engine that makes our local networks go. But its entire foundation is built on a level of trust that, frankly, can be shattered pretty easily. And that leaves us with a really fascinating challenge, right? The protocol that lets our devices talk to each other was designed way back in 1982, a totally different universe technologically speaking. So the question we have to grapple with today is, how do we protect a 40-year-old protocol that was built for a friendly neighborhood in a world that's increasingly built on the idea of trusting no one?